Hello everyone, welcome to Unacademy. This is Debashree. I'm working as an assistant professor. If you want to join Unacademy Plus, you can join it with the help of my referral code, that is DEBA1. So what are the benefits of the Unacademy Plus are daily live classes, structured courses as per the CSIR syllabus, live tests and quizzes, unlimited access to all the educators at single subscription. So if you want to join Unacademy Plus, you can join it with the help of my referral code, that is DEBA1. So if we move to the price list, if you join for 1 month, the price will be around 1890. For 3 months it is to 4725. For 6 months it is 8505. For 12 months it is 10,395, and for 24 months it is 15,120. If you use my referral code DEBA1, you will be getting a 10% off on all this. So to get the maximum benefit at the minimum price, you can use my referral code and you can be a part of the Unacademy family. So let's move to our topic. So today we are going to see the spectroscopic techniques. Spectroscopic techniques we will discuss in this class, right? Okay. Great. Fine. Spectroscopic thing. Today we will be discussing one spectroscopic technique one by one. We will be covering up in each classes, right? Okay, fine. So okay, electromagnetic spectrum. So before going into detail to the spectroscopic techniques, first we need to know electromagnetic spectrum, because everything starts from electromagnetic spectrum, right? So if we talk about electromagnetic spectrum, these are basically, we can define electromagnetic spectrum as the entire range of light that exists from the radio waves to gamma rays. So basically, if we define electromagnetic spectrum, it is different ranges of wavelength, right? Different ranges of wavelength, we will name them according to the wavelength and we will group them as a whole. We call it what? Electromagnetic spectrum. So it basically includes what? Electromagnetic spectrum includes your cosmic rays, right? Gamma rays, clear? UV rays, 1 minute. X-rays, UV rays, visible rays, infrared rays, microwaves, and radio waves. So these all are having a particular wavelength. These all are having what? They all are having a particular, or you can say specific wavelength, right? According to that wavelength, we named it as a wave, right? For example, let me give you a very good example. If we talk about UV rays, the wavelength ranges from 200 to 280 nanometer, right? So that is the UV rays wavelength, right? So this is the example of electromagnetic spectrum. It has, why we call it electromagnetic spectrum, because these waves are having both electric and magnetic properties. Includes both electric and magnetic properties, right? That's why we call them electromagnetic wave, because it includes both the electric and magnetic properties, right? So it includes different ranges of wavelength. According to the different ranges of wavelength, we named it cosmic rays, gamma rays, UV, X-rays, UV rays, visible rays, infrared rays, microwave, and radio waves, right? So light is an electromagnetic radiation, a phenomenon exhibiting different energies, and dependent on that energy, different molecular features can be probed. Okay, fine. So what is electromagnetic spectrum? Basically, it is a range of wavelength which are having you can say it is different ranges of wavelength. According to the wavelength, there are many very different types of waves, right? And they are having both electrical and magnetic properties, so we call them electromagnetic wave, right? Okay, now what is spectroscopy? Spectroscopy is what? It is an interaction of electromagnetic radiation and the molecule. Suppose this is a light, right? This is what you can see here. This is a light, right? And this is our sample. Our sample means it can be your proteins, right? Can be DNA and can be RNA. So when the light interact with the protein, with the sample can be anything. Either it can be a protein, it can be a DNA, it can be a RNA, right? So when the light interact with the sample, there occurs some changes in both the sample as well as in the light. So this changes, we call this interaction of light with sample. The study of the interaction of light with sample, we call it what? Spectroscopy. Spectro plus scopy. It deals with the study of the interaction, study of the interaction, study of the interaction between light and sample. Am I clear? So what is spectroscopy? It is basically the interaction between the light and the sample, right? So what will happen? Whenever the light interact with the sample, there are changes in the sample as well as in the light, right? And according to that, there we will get, and because of these changes, we can use those changes for studying the structure and concentration of a biological sample, right? So when a light is interacting with sample, three things may happen. Either there is an absorption of the light, emission of the light, and scattering of the light, right? So whenever the light interact with the sample, there is a possibility of three things. What are the three things? Either the light absorb, right, or it undergo emission, or it undergoes scattering. Out of these three, it form only one or two. So that is what we call it spectroscopy. And whenever the light interact with sample, the changes can be absorption, emission, scattering, right? So these are the changes basically takes place whenever the light interacts with any sample. Next, if we define scattering, emission, and absorption, let's see. So coming to the scattering spectroscopy. So if we talk about the scattering spectroscopy, what does the scattering means? Amount of light that a substance scatters at a particular wavelength. So suppose this is a light coming. When it is interacting with the sample, what the sample is doing? It is scattering the light. This is what we call scattering, right? So the wavelength dependent behavior of light scattered by living cells reveals structural and functional information that is not readily available with traditional microscopy methods. Now what will happen? There will be one screen, and on this screen this scattered light will form. The more denser, the more darker spot it will be observed. So this basically helps us in getting the information about the structure. Coming to emission spectroscopy, what is emission spectroscopy? Emission means something emitted. So suppose this is you can say if this is a light. For I am writing this is first, this is second, and this is for second one I am explaining. If there is a light, it will interact with the sample, right? So what will happen? The sample will absorb a wavelength of the light, right? Sample will absorb the light, and after some time what will happen? The sample will emit the light, right? Sample after some time, sample will emit light. After some time, sample will emit light of longer wavelength and lesser energy. Longer wavelength, lesser energy. As the sample is emitting light, so we call it emission spectroscopy. And for emission of light by the specimen or sample, we need to stain it with fluorochrome, right? So we need to stain it with fluorochrome, and once it is stained, what will happen? Whenever the light interact with the sample will absorb the light, and after some time it will emit the light of longer wavelength and lesser energy, right? And this can be used for detection of the concentration as well as the structure of a sample. Coming to absorption spectroscopy refers to the spectroscopic techniques that measures the absorption of radiation as a function of frequency or wavelength due to interaction with a sample. So what will happen in case of absorption? As the name suggests, it will undergo absorption. Whenever the light interacts with the sample will absorb certain amount of light depending on the sample. If the sample is having more protein, it will absorb more light. If it is having less, then it will absorb the less light. Right? So this is basically the principle. Whenever a electromagnetic spectrum interacts with a matter, there exist three types of changes, that is scattering, emission and absorption. Right? So once these changes is done, you can use the structure, you can use it for determination, or for, you can say, for evaluation of structure and concentration of biological samples. Coming to the properties of electromagnetic radiation. So if we talk about the properties of electromagnetic radiation, it has energy, no mass. It do not have any mass, only it is having the energy. It can travel through a vacuum. Of course, it can travel through a vacuum. That means it do not need any medium. Do not need any medium, right? So it can travel through vacuum. It travels in wave motion. It travels at the speed of light. So it can travel with the speed of the light. Each wave has a frequency which is related to energy. So the relation between wave frequency and lambda is E is equals to h nu. Nu is your wave speed of light in air, right? So it is replaced by C by lambda, right? So this is what is your electromagnetic radiation properties. Next, this is the formula already I told you. What you need to notice here is energy is inversely proportional to wavelength. Energy inversely proportional to wavelength. If energy increases, wavelength decreases. And even if energy decreases, wavelength increases. Right? So this is how it happens. So these are the radiations along longer, higher energy, and you can say lesser wavelength, right? Similarly, for it, this is in terms of energy. If I explain this in terms of wavelength, it will be having the lowest wavelength, and here it will be having the highest wavelength. Clear? So this is basically the types of waves that are present under the electromagnetic spectrum. Okay, let's discuss the principle of spectroscopy. Principle of spectroscopy depends on Beer-Lambert's law. So this is one scientist and this is another scientist who gave a statement for the absorption of light and the sample. So whenever we combine them, it forms the Beer-Lambert's law. So what was the statement was, Beer gave a statement that whenever a light is passed through a sample, then there are certain changes in the light. So what are the changes is the sample absorbed a light, right? So and that light is directly proportional to the concentration of the sample. According to Beer-Lambert's law, what Beer told is the light absorbed by a substance. What Beer told is light absorbed by a substance dissolved in a fully transmitted solvent is directly proportional to the concentration of a substance. So if it is light, light is directly proportional to the concentration. Concentration means what? The amount of substances which are present in the sample, right? So if the light absorption will high, if the concentration of sample will high, right? Light absorption will be less when the concentration of sample will be less. Clear? So, and according to Lambert's, what they told, the amount of light absorbed is directly related to the path length. This is path length. So whenever we combine both of them, we get a common law, that is, which states that the light absorbed by a substance dissolved in a fully transmitted solvent is directly proportional to the concentration of the substance and path length of the light through the solution. Right? So Beer-Lambert's law defined the biological sample with the concentration. He told that whenever the light absorbed by any substance or by substances dissolved is directly proportional to the concentration of the substances and the path length and light through the solution. So in this class, I have discussed only electromagnetic spectrum, and from next class onwards, we will go into detail about the each techniques. Next class, we will be dealing with the UV visible spectroscopy, and this is very small video on electromagnetic spectrum, right? Thank you so much, students, for watching. If you want to join Unacademy Plus, you can join it with the help of my referral code. You can also subscribe to our channel, hit the subscription bell, right? Thank you so much, students, for watching this session. Bye bye. Take care, everyone.